welcome to our session, Satellites as Storytellers. We're so thrilled to have you join us. Thank you to all the folks online. We're gonna have a wonderful session with you today and show you, kind of immerse you into our Earth observing satellite data with the sole purpose saying, what's the impact here on Earth? Open data for all, and what's the most important impact? How can we act every day on the benefit of what I call Spaceship Earth? So glad to be here with you today. And I think let's get started. We have over 1,100 satellites orbiting Earth. They're in low Earth orbit. We call this eyes on Earth, looking down at all the vital signs. Almost now in real time, you could serve up this data, just even on your phone. So what are we measuring? The vital signs, the systems of systems, all of Earth's systems. So if it's precipitation, what about the cloud coverage? What about rainfall for agriculture? All of the storms, weather in the near term, today, tomorrow, you care about the weather. What about longer term forecasts? There's the sea currents. We're going to talk a lot about the oceans and Earth's main system. So looking at our beautiful blue marble from space. Again, eyes on Earth. And these are the vital signs of Earth. So that's our space perspective, but down for Earth. So what's this? Carbon dioxide. Let's start with this vital sign. The CO2, the largest contributor to our greenhouse gases, are here. Again, this holistic Earth view, looking down on Earth, the emissions of CO2 covering the globe. We are at 420 parts per million today. We want to be below 400, increasing. So if we turn here, what we've done with open access data, all of that satellite data for our CO2 emissions, but now it's superimposed to also fossil fuel use, and specifically the emissions and the burning. So now you have in real time coverage of the Earth, but the CO2 emissions, the burning of the fossil fuels, the largest contributor to greenhouse gases, and you can see it mapped across highlight the intensity across the entire globe. So I want to talk about temperature. 2023, hottest year ever recorded in millennia. How was your 2023? We smashed our records. Matter of fact, every month. So this is the world's temperature, global temperature since 1880 going till today. Blue is 1 to 2 degrees Celsius below an average mean of 30 years. Yellow and orange is 1 to 2 degrees Celsius above that 30-year running mean. It's hot. It's extremely hot. This is just our scientific data, the vital signs. The globe is heating. It's heating very quickly. Let's dive into this data a little bit deeper. Same data, show you the 1960s, the same data. There's average 1 degree, -1 degree C, that blue, but what you're gonna see, it's all pink and red. What does that mean? So I kind of like to tip it here, 3 dimensions for you. There we go, 2023. Our hottest year recorded, month by month by month. The heat waves, the displacement of people, causing, really suffering. And what can we do about this? This is not the gloom and doom scenario, but again, just to show you the data that we have. Tens of thousands, again, the satellite data I mentioned, Earth observing data, but guess what? We also fly aircraft to the atmosphere, and we have sensors, tens of thousands of sensors all over the land and the ocean to make these very comprehensive, open source data sets for you all to dive into the data. Same data, temperature data. I want you to concentrate here on the top half, the Arctic. So we go through the 144 years of this global record, a little bit below average here, 1800s, get to the 1900s. Now look at the north. The northern hemisphere is heating much quicker than the rest. And I want you to take attention to the Arctic, the poles, and Antarctica down here. So now when you see the red covers, now we're 1 degree above that 30-year running mean. And now in some places, especially in the Arctic, we've already blown past 2 degrees Celsius average. So, I want to tell you about the poles now. Let's talk a little bit about our ice sheets. So in particular, Greenland and Antarctica. Oh, that's the next one. First, the oceans. I want to make the point here with, again, a global set of data before we zoom in to our oceans. This is ocean heating. We're showing you a lot about temperatures globally, but the oceans are absorbing the vast majority of the carbon. And so they have the major role to play in our ocean subsystem, Earth's largest system. And here's the color coding, and so you can see, especially the equatorial range, how hot the oceans are. If you live close to the ocean, chances are you do, because the majority of population of the world lives within 100 kilometers of the ocean. You've probably noticed it. I just flew in from Boston. I'm not supposed to be able to swim all summer. Now our oceans are very warm. I used to have a wetsuit. Well, I don't have my wetsuit anymore. That might be nice for me, but that's not nice for the biodiversity and all living beings and the transitions of biodiversity in our ocean systems. Okay, now I mentioned the poles and the Arctic, a theme, for the World Economic Forum this year. So this is just the last 2 years. What I'm showing you is just the last 2 years, 2022, 2023. 99% of the world's fresh water is trapped in our ice sheets on Greenland and Antarctica. So this will circle through so that I can explain it. So it's seasonal. So for winter time here in Greenland, it reaches a peak in March and summer in September. So that's the low at the end of the summer for Greenland. Now it's winter in Greenland. Okay, March, that's the peak ice, sea ice as well as land ice. It's reverse in Antarctica. So here if we're in Antarctica, take a look. I just got back from Antarctica. So we're gonna see a low now here, the end of summer in March, and then it builds up in the winter. I was just right there. I flew in from Argentina, but Antarctica on a boat, the Drake Passage, that's something. A little dicey. But it was so important to go see, again, the biodiversity, to see firsthand, the glaciers melting before your eyes. I love Antarctica. I've been to McMurdo Base, the South Pole Station, our bases, but now the peninsula, because again, that's where it's melting faster. And in total, about 400 gigatons of ice. What's that mean? Well, that's a lot. It's a lot. So let's take a look at Greenland in particular. As I mentioned, the Arctic and the poles. So this is the last 20 years, and we measure, the velocity, not just our glaciers melting. As I mentioned, 99% of the world's fresh water trapped here. This is really important for sea level rise. I showed you the oceans and heat because the expanding temperatures, that increases sea level rise. But now when we see our glaciers melting, and look at this, just the last 20 years, in terms of meters of water equivalent, this is how much Greenland is melting. We take our IceSat, is the satellite that measures this, every day. We're in polar orbit looking at these. So you can see here, I'm showing you every month in terms of the decline of the ice sheet here in Greenland. It was, on average, it's 270 gigatons. Total, if we add Antarctica, that's about 400. Well, how much is 400 gigatons per year? Well, that's the size of Texas and California combined in surface area. It's a lot of ice, hence leading to our sea level rise, and specifically in the last couple decades. Now, you might say, okay, well, it's a couple centimeters of sea level rise, yes? But it's accelerating. It's going up and exponential. That's why we're so concerned. So a lot of data, kind of immersing you in the data, these vital signs of global phenomena. We're all in it. Now I want to take you into an experience we call the Earth Mission Control, because we want to give people agency. What can you do about it? It's not about the data. It's about transforming human behavior. It's about taking action. So jump into our virtual reality goggles. They're here. This is just a video. You see the globe. You see spaceship Earth. And then what I want you to do is, again, to have agency. You decide where you want to go in the world. It's educational, informing people about all of our satellites, as I've just mentioned briefly here. But then what you care about is where you live, where your people live, where your friends and family are. So you want to go anywhere you want. So okay, I care about water, or maybe rising sea levels because I'm in Boston. So the same data kind of that I've shown you is global data sets, but then a narration, and this is in virtual reality, and so we design it with the components of the globe, those dashboards that you get to decide. Maybe you care about CO2. This is actually in Galveston, Texas, going into Houston, one of our largest cities, and looking at flooding data, looking at how is the sea rising. The next flood is coming to Houston, I guarantee you. I just can't tell you when. We'll talk a little bit more about that. What about island nations? This, I've picked Hawaii. Now, I put the Antarctic backdrop because I just got to see literally these glaciers melting last week, proof of evidence, but not everyone gets to go to Antarctica. We want to put you into the scene. We want to give people this experience. When you're looking at it in 360, it's very, very compelling. Very compelling. And I'll just pause and say, some friends and colleagues here too from the European Space Agency. Hi, Matthias, Joseph, great to see you. And we use these kind of simulations and this, Earth mission control, space mission control every day in our space research. At Mars, we're at Mars, right? Looking at the data, showing 360 views. So rather than just talking about it or having it here on the screen, if we immerse you in the data, now that gives you real agency. Now you can take an action. You're a decision maker. It's all about transitioning the data into humans taking action and transition. So this is now, let's go to Hawaii, talk about flooding a little bit more. When you're in the virtual reality or augmented reality, okay, there's your city, there's Honolulu, small version of it. Here's the dashboards again. What does sea level rise look like? I type in my zip code. I want to go to Honolulu. I want to go to Kailua, right where you live, so that it's very meaningful to you. Kind of page through the different dashboards, you just throw up the dashboards, and then we can all convene around the table. We actually call this the decision table. Now, what it's missing is the people. I need all of you and myself. You need the city planners. You need someone who lives right there to say, okay, what's the impact perhaps for me? And more importantly, what are the policy decisions? How do you get people out of harm's way? So again, it's interactive, 1.5, 1.8, we're gonna go up to 3 meters, not centimeters. Now we're 3 meters, because right now we have over 15 centimeters in Honolulu, Hawaii. And this is coming. This is the future that's coming. So what about urban planning? What's gonna happen? So this really has the economic consequences that are amazing. This is a $2 to $3 trillion per year because of natural disasters in a recent World Economic Forum report. But I think you need to be there, you need to go around the world, you need to really kind of see the data from this perspective. Okay, so we've used AI, machine learning for flooding. Again, to give people agency to what I call the pocket climate. I want you to have climate and the data I'm showing you right in your hand, so that it means something to you. So this is Houston, Texas again. These are real images up top. Pre-flooding, these are real images. Now we've used machine learning, generative AI on the bottom. So this flood hasn't happened yet, but I know it's coming. So we want to give people agency, and there's a slider there, again, so you're in charge. So if that's your real estate, if that's your infrastructure, if that's your business, you're going to be underwater. So again, we can just show, we call this satellite imagery of the future. It's coming, and so we can put this literally in your hand so that you can make the best decisions. You can work with city planners so that everyone can, really this is about saving lives, keeping people safe, getting you out of harm's way. Want to jump to my last little section here on fires. If you haven't seen the flood recently, well, guess what? I bet you've been affected by a fire, or your friends and family. Because we've also just come out of the worst fire season that we've had. So this is actually now looking at real-time fires across the world. So I want to give one example, deep dive. This is Yellowstone. This is Yellowstone National Park. And it's, from over 20 years ago. You might recall or have heard of the Great Fire in our national park of Yellowstone in Montana, Wyoming. I'm from Montana originally. This was sad. This was incredibly sad. Really burned like crazy. That's the red. You see the red. But the reason I showed it to you, guess what? It has recovered. It has recovered. Now you'll see the green coming in. So over these 2 decades, we see the replenishment of the trees. You see the greening. We see a few more fires. The fires are here in red. But I want to make sure that, we have some hope. We have some optimism. We have this future that if we take control, if we kind of, again, immerse ourselves in the data, understand the data, it's just a scientific data, and then we say, what's the important thing? The important thing is the people and our decisions. What are our decisions? What are our actions every day that we're gonna take on behalf of all biodiversity, all of our oceans, as well as people here on Earth to relieve the suffering? And all that temperature data, 2023, hottest year we've ever had. Guess what? It's the coolest year of the next 100 years. So we're here. This is how, our Earth observing satellite, we can immerse people in the data, but we can give people agency. What decisions should we be making for the betterment, of our local communities, but globally overall? I'm optimistic. I think we can do this. And now I have the great pleasure to welcome a colleague and a friend. Zach's going to join us here on stage and give a little bit of presentation. Zach runs DC VC Venture Capital, has been investing heavily into Earth observing data, satellite data for Earth, specifically for Earth. He's an expert and interested in the energy transition, using space data for Earth, also a little bit of nuclear fusion. So Zach, thank you so much for joining and welcome.
Thanks, Dave. Thanks, David. Great. What a great talk. So hey guys, I'm a early stage deep tech investor, and my role is to talk about commercialization of Earth observation data. And as a deep tech investor, the name of the game is commercialization. We take the old Steve Jobs quote of real artists ship, and we say real deep tech entrepreneurs commercialize, because it's not enough to have a cool technological breakthrough. And so I'll sort of frame the talk with sort of two thoughts on commercializing Earth observation data. So one, there's a plunging cost of being able to launch stuff into orbit. So you can do really terrific things in orbit these days, but still you need to find someone down on the planet that's willing to pay for it. That's number one. And number two is that the largest purchasers of Earth observation data are large governments, with the largest being the US government. So if you're thinking about commercializing Earth observation data, that needs to have the G20 in your roadmap, because they are such large purchasers. So my first slide here, this is a picture of Poyang Lake in central China, in rural China. It's China's largest freshwater lake, and this is sort of 1 year apart. And this lake is crucial for the local rice cultivation. And this was from 2021 to 2022, massive drought. And obviously a huge impact on the local farmers. And this is in a rural area, so without Earth observation data, you're not able to monitor that. And increasingly, the saying is that if climate change is a shark, in which we saw some great data, so if climate change is a shark, water is the teeth. And so being able to monitor water and react in real time, and maybe give these farmers a heads up that there's going to be a shortage of water, and to adjust their crop mix accordingly, is going to be increasingly important in the modern world. This next one, if you guys recall, a few years ago when the oil tanker managed to get itself lodged in the Suez Canal. And that was a big deal, right? It actually snarled supply chains pretty quickly, because we're living in an increasingly interconnected world. And to monitor and manage an interconnected world, you really need Earth observation data to be able to react to this and stuff in real time. This is a picture from Capella Space. And the cool fact about this was taken at night. And so I like to say no photons were harmed in the making of this picture, because Capella uses a technology called synthetic aperture radar. So they're just actually using radar from space to look down at the Earth and actually be able to perceive things through clouds or at night, or just when there's no light available. So this is actually pretty cool imagery, and you can imagine there's lots of use cases for when you need to see stuff on the surface of the planet when the sun's not shining or when it's cloudy. And my third example, obviously climate change. We've talked about that a little bit, but over half of the variables we need to track in order to track climate change can only be tracked from space. And this is a cool partnership between Planet Labs and Carbon Mapper. And this is actually taking measuring and taking a survey of all the above ground carbon. So how much carbon do we actually have above ground? And this is sort of, you can see there, I think obviously there's the big rainforest in place where there's the big forest, but they actually can track this down to the region. So the landscape, and actually down to the individual tree level, and you can crunch and just basically calculate the amount of carbon that we're storing above ground. We obviously need a lot more trees to help draw down. There's many other problems that we need to solve in the climate change, but this, being able to manage and understand how much carbon we currently have above ground really will help manage that. And sort of in the face of climate change, we need sort of every tool in our toolkit needs to be developed, and this is actually a terrific one just to be able to understand where we are. And with that, so those are three great commercialization use cases: water, just imagery sort of at all times of day, and also above ground carbon for climate change. And with that, I think David and I can take some Q&A.
Oh, good. There's a mic right here. There we go. Thank you.
Please introduce yourself.
Thank you. I'm Joseph Aschbacher. I'm the Director General of the European Space Agency. I think you know me very well. I used to be in charge of Earth observation, as you know, before becoming DG of ESA. So I know these images which you have shown, fantastic images, very well. But my question is more, where do you see, first of all, I think today we have an enormous set of data. We have observations from some of the best satellites. By the way, Europe also contributes a lot to the Copernicus program, as you know. But we have fantastic observations. But what is your next projection? Where do you see what is coming next? A question to you, but also to you then from a commercial perspective. Sometimes people say in space, of course, we have the commercialization of telecoms through all the services that are there. Navigation, of course, has a huge commercial potential and development, and Earth observation is next. So where do you see, from an investment point of view, the main trends, the main opportunities, and what do you do from your perspective in order to stimulate it, make it grow, and make it happen?
Great. So I'll start, kind of from the science, the technology, from the government's perspective and academia. It's amazing. These used to take years and years, these huge comprehensive data sets, and you would wait, and then as academics, you'd publish a paper. Now, it's daily. And it has to be trusted data. That's why I wanted to show at least a little bit of AI machine learning. These are open data sets, so everyone can take the data, replicate them. So that's really important. We start from not just the amount of data, but the trusted data, kind of how it's curated, how we're going from the hyper to the local, put it in everyone's hand, kind of open source, citizen science we're very fond of. Let everyone participate, put everyone kind of in that Earth mission control, because they make us all better. So that's where I take it from. It's amazing how precise the data is getting in your example of down to the tree level. So you can really zoom in, understanding the big picture. Astronauts all go into space. Guess what? They look down on Earth, the overview effect. Every single one is transitioned, mentally, physically saying, look at that beautiful spaceship Earth. And so they just have that. And can we give that to everyone? That's what so we share the data. Everyone's an astronaut. We've lived through the pandemic. We survived. You've been in isolated, confined environments. And now when we reflect and have that perspective about looking down on our beautiful Earth. So that's for me, the real time, the precision, letting people, give them agency to play around with the data, help us even with new discoveries. And that's why I'm super optimistic, because it's just the most exciting thing I work on every day is like, what are those positive actions that we can take, get this in the hands of all of our academics, all of our students growing up, all of our policymakers, all of our government officials. Now I'll hand it over to the economic, the industry perspective.
So yeah, I mean, just even a handful of decades ago, Earth observation data was only available to the biggest governments. And that's because Earth observation satellites were the size of Volkswagen buses, and it took decades and tens of millions of dollars or hundreds of millions of dollars to launch these things. Now they're the size of a loaf of bread. You can launch these things almost continuously with private launch, with publicly funded launches, and now the data is not just available to government, it's available to everyone. And really the goal is to make the world transparent. So now everyone sort of has the equal footing and can see the Earth and can see the changes. It's also of a different granularity. So it used to be that the spy agencies could see very precisely. They had big telescopes, so they could see really down. But now it's the time granularity, where you actually now can see a snapshot of the Earth every day. And then what's the trend, or how does that actually begin to manifest? Because a snapshot of every square inch of the planet, and there's also weekly. Like obviously, Sentinel data is a terrific data set as well. But these Earth observation data sets that cover the whole planet on a very rapid timescale, those are some of the biggest data sets we've ever seen. They're too big, obviously, for humans, and in the government they used to look with the little magnifying glasses. Now, how do you actually make sense of all of that data? It's with AI. We saw a little bit of generative AI in David's presentation, but just doing the simple change detection is a big AI job if you're looking across the entire surface of the Earth. So it's increasingly figuring out how these new novel data sets that weren't always available, that are just now available, and we're in the early innings of how people are figuring out use cases to commercialize those and use those to otherwise sort of benefit the planet.
Yeah, great.
Michael Mainelli, coming out of the City of London. I was just curious, as an investor, how do you assess the space debris, space junk problem as a risk?
So it's absolutely a problem that we need to track. It's not currently a problem. It's kind of like we're seeing the beginnings of sort of the pollution, right? If you think about it, and there's still a lot of space up there in orbit, but it's an increasing problem, and obviously it's a kind of thing that causes a cascading effect. So you need to be aware of it when you're investing, but it's currently not really impacting a lot of especially the low Earth orbit satellites, because those satellites all go up there and deorbit. So in those orbits, there's not as much debris as there are in the higher orbits. But there's also very plausible techniques to sort of ameliorate that, of just sort of ground-based lasers that sort of slow stuff down so it actually then deorbits. But it's something we need to track. We need sort of global participation, and we need global multi-stakeholder cooperation to make sure it doesn't become out of control, because obviously having the ability to observe the Earth and have communications in space is very important.
Yeah, and I might just add, and we need the standards and the policy. Yeah. We're not there yet. And so thank you for that question as well. Space, debris, space situational awareness is a very high priority area, and let's get the policies and responsibilities for people to deorbit, make sure we can deorbit safely, cleanly, so we don't have a worse problem in orbital debris.
Maybe what Zach was just saying on the debris issue, there's just a zero debris charter which has been adopted very recently. It's open for signature now. A number of space agencies, operators are now signing up. I think this is an initiative that really, what you mentioned, the debris issue, it's a huge problem. We are still lucky enough, I would say, that we are not yet affected. There's no major collision among them, because the famous Kessler effect, of course, is the one everyone is scared of. If a major collision happens and then triggers on, collides with the next one, with the next one, with the next one, then the whole orbits become unusable. And that, of course, is a fear that we all have from space. So now we are tackling it with our partners in the US, in Europe, and I can only invite everyone to really join to this, because we have 30,000 of these debris above of a tennis ball size. We have millions that are much smaller. So it's a threat that is there, and luckily has not yet affected us.
I want to thank everyone for your time. Zach, thank you very much. Thanks to the audience, and thanks to everyone online.
Yeah.